Hi Pre-Calculus, welcome back. Our objective is going to be to find vertical and horizontal asymptotes of rational functions today, as well as some x-intercepts. So go ahead and I'm going to force pause on the screen. You know what to do from here. All right, force pause on your screen. Can you just please copy the three expressions I have on the left? All right, so for each of these three, we would like to set them equal to 0, okay? But what I would like for you to do is factor them if they are factorable. So for example, x squared minus 9 can be rewritten as x plus 3, x minus 3. So if I set this equal to 0, then I would get x equals negative 3 and positive 3, okay? And force pause on your screen. Can you do parts B and C for me? Hit continue when you are ready to check your answer. All right, so I got negative 2 and negative 4 for part B and just 1 for part C. So what we're going to do today is just take these three expressions and kind of mix them around and create some rational functions with these three. Okay, so sometimes you might see like x squared minus 9 on the top and like x minus 1 on the bottom, etc. Okay, so we're just going to play around with these three expressions today. Now, let's also define what a rational function is. So one good mnemonic is rational fractional. Okay, so a rational function is a function that is looks like a fraction. So you've got one polynomial over another polynomial. All right, and press pause on your screen. I've got a split screen here. I've got my notes and Desmos pulled up. But can you go ahead and copy the equation that I have as well as the four pieces of information I want to find? So go ahead and copy that. Hit continue when you're ready to continue. All right, so what we're going to do is explore some of these rational functions graphically with Desmos and then see if we can come up with some generalizations. Okay, so I've gone ahead and graphed y into Desmos, and the first thing I want to point out, what are the x-intercepts you found for the numerator and for the denominator? So remember, we found, let's see if we go back a slide, like x minus 1 was equal to 0 when x is 1, and x squared minus 9 was equal to 0 when x was plus or minus 3, okay? All right, so let's first look at our x-intercept and 0 of this red function, which is y, this rational function. Remember, rational is fractional. So what are my x-intercepts or my zeros? Well, I just have 1, and it's x equals 1, right? And do you remember where that came from? Yeah, that came from when the numerator, x minus 1, was equal to 0, right? This is a 1. Okay, now let's look at vertical asymptotes. So it looks to me like I have, and let's graph them just so you are convinced that I have vertical asymptotes at negative 3, x equals negative 3, as well as x equals positive 3. Those look like the vertical asymptotes, right? So x equals 3 and x equals negative 3. And those came from where? Those came from when we set the denominator equal to 0, right? All right, horizontal asymptote. Can you tell what the horizontal asymptote is? Remember, an asymptote is a line that our function approaches. So horizontal would look like this, right? Parallel to the x-axis. So what do you think about y equals 0? Does that look like what we can approach on the far left, far right? Yeah, this is y equals 0. Where does this come from? Okay, this comes from the degree of the numerator versus denominator. So look at the degree of the numerator. Its largest exponent is 1, right? What about the degree of the denominator? It has an exponent, largest exponent of 2, right? So which one's bigger? 2 is bigger, right? The denominator is going to take over as x approaches plus or minus infinity. Here's what I mean. And let's just look at line 3 here. Let's take let's take just 1 over 10. Okay, 0.1. I'm looking at this number here. What I'm going to do is I'm going to make that denominator take over. In other words, it's going to get bigger and bigger and bigger. So as that denominator gets bigger and bigger and bigger, as this approaches infinity, look at my number. It's getting teeny tiny. This is 1 times 10 to the negative 17th power, okay? So this number is approaching 0, all right? So if the degree of the denominator beats the degree of the numerator, then you're going to have y equals 0 as a horizontal asymptote. All right, so now let's look at the range. If you look at this middle piece here, you can tell that all the y values are covered. So the range is going to be negative infinity to positive infinity. Let's also think about domain. So the domain, there's three pieces. In other words, there's two gaps. So I've got a gap at x equals -3 from this vertical asymptote, and another gap at x equals +3. So the domain is going to be all real numbers except -3 and +3. And I can write those three pieces like so. Just keep in mind that you have parentheses, not brackets. All right, I'm going to force a pause on your screen. Can you go ahead and go to Desmos and graph this rational function for me, and then answer, we've got domain on there twice. Go ahead and answer these 5 aspects for me. Hit continue when you're ready to check your answer. All right, here's what we should have gotten. Our x-intercepts are at x equals -4 and -2. Our vertical asymptotes, if we want to kind of maybe zoom out here again, but then you're going to get x equals -3 and x equals +3 for your vertical asymptotes. So your domain is all real numbers other than -3 and +3. Now, for your horizontal asymptote, look here, it's going to be y equals 1. So again, look at your exponents, or your degrees. The degree of the numerator is 2, and the degree of the denominator is also 2. Same exponents. So they need equal representation. All right, those terms are going to take over. So take your leading coefficient of the numerator, which is 1, divide it by your leading coefficient of the denominator. Hopefully you remember this from Algebra 2. That's also 1. So 1 divided by 1 is your horizontal asymptote. So y equals 1. Be sure you give an equation there, not just a number. So here is our final answer for all 5 aspects of that equation. All right, force another pause on your screen. Go ahead and type this last rational function into Desmos and answer these 5 aspects for me. All right, so here is my function graphed. I've got x-intercepts when the numerator is 0, right, at -3 and 3. I've got vertical asymptotes when the denominator is 0, and you might need to zoom out a bit and see, okay, yep, x equals 1 is believable there as the vertical asymptote, right? So the domain is all real numbers other than +1. And for horizontal asymptote, we don't have any, right? And why is that? Well, that's because as the degree of the denominator is smaller than the degree of the numerator. So this power of 2, the numerator takes over. As the numerator gets bigger and bigger and bigger and bigger, it doesn't approach any certain number, it just approaches infinity. So no horizontal asymptotes there, and range all real numbers. So here is our final answer for that equation. All right, so let's summarize these 3 aspects and how we can find them without looking at a graphing calculator. Go ahead and pause and hit continue when you're ready to fill it in. All right, for x-intercepts, you're going to see where the numerator, let's see if I can grab the correct pen here, so see where the numerator is equal to 0. For vertical asymptotes, factor and see where the denominator is equal to 0. This would be after any cancellation, okay? So we're going to set denominator equal to 0, and this is after, if you have factored both numerator and denominator, this is after you factor cancel. Factored and canceled any common factors. And then horizontal asymptote, where that's where we look at the degree of the numerator versus degree of denominator. Hopefully you've seen this acronym before, called Bobo Botten eats DC. So write this for me. Botten eats DC. Okay, so this is kind of our little acronym for horizontal asymptotes. So if you have bigger on bottom, and remember I'm talking degree of numerator versus denominator, this is supposed to look like a 0. So you have y equals 0 as your horizontal asymptote. Bigger on top, none. That was like our last example when we had this one. Remember, we had no horizontal asymptote because we had a larger exponent in the numerator than the denominator. HDC exponents are the same, divide, coefficients. Okay, so my last screen, I'm going to have three rational functions for you. You tell me the horizontal asymptote. All right, I'm going to force pause on your screen. You go ahead and tell me the horizontal asymptote at each of these three functions. Hit continue when you're ready to check your answers. All right, answers are on the screen along with their corresponding part of the acronym. And that is all I have for you today. I will see you all next time.